Hi, as a nanofossil specialist on board the Jori Resolution and IODP expeditions, our task is to tell time. And we can do that fairly quickly, pretty much maybe half an hour after the cores come on deck, because we get a small piece of the core catcher, which is the lowermost point of the core that comes on deck, and we can process that fairly immediately after we receive that sample, and we look at that in so-called smear slides and then look at it under the polarized light microscope, and that is normally at the magnification of about 1,000 times. So we're looking at very small things called calcareous nanofossils, and these calcareous nanofossils are derived from marine algae that have a very long and extensive and very complete fossil record, and predominantly in marine sediment, so that's why we're out here. And these organisms have evolved fairly rapidly over time, and evolved in terms of shape and sizes and different groups of algae. And because they evolved fairly rapidly, we can really quite easily, by telling or identifying what type of species are in the sample, we can bracket time by knowing when they lived in geologic history and when they died out, so then you wouldn't find them in the younger sediments, and you won't find them either before they ever lived on this planet. So it's really nice a nice system to bracket geologic age. And we're not just looking for one species, we're looking at the assemblage and different species coming and going through time, and that's how we can tell time as we drill downhole and go deeper and deeper and older and older.